Welcome! In the second section, we will try to create machine learning at scale. So we will be focusing on techniques that allows us to create very efficient and performant machine learning algorithms. So firstly, we will start from looking what a feature engineering is. Then we will try to distinguish between supervised learning and unsupervised learning. So we will see that that first type is used when we have data that is labeled, and we will try to consider examples of when to use it. And on the other hand, then we'll be using and looking at the examples from unsupervised learning world. That will be, for example, clustering. At the end of this section, we will implement recommendation engine that allows us to answer a question if the user will like a movie. And this is a first video in which we'll be looking at the topic of feature engineering. So we will answer a question of what feature engineering is and why this is so important. Because feature vector, that is a result of feature engineering, is the main building block of every machine learning algorithm. And at this stage of feature engineering, everything is starting. Next, we will see how to extract features from data. So we are given a raw data, for example text data or data that has a lot of different parameters, and we need to extract some meaningful features from that data. This is not a simple task, and we need to try and learn multiple times. So let's answer a question what a feature engineering is. So this is a process of using domain knowledge of the data to create features that make machine learning algorithm works. So this is a most important stage in every machine learning program. Feature engineering is the process of transforming raw data into features that better represents the underlying problem to the predictive models, resulting in improved model accuracy on unseen data. Choosing proper features, feature vector, could be really effective, could make our model work as good as possible. So what a feature is? Because feature vector consists of multiple features, so we need to understand and answer a question what the one feature is. So feature is an attribute or property shared by all of the independent units on which analysis or prediction is to be done. So every record, every unit that will be analyzed by our machine learning program needs to have a same feature present, because we'll be comparing feature of every record to classify them somehow. Any attribute could be a feature, as long as it is useful to the model, and this is a role of analysis of machine learning programming expert to choose proper feature for every model. So we are speaking about features, but let's see how does it look like in a real world example. So let's say we are given some kind of problem, and then we need to try to find features for that specific problem. So this is an example first. So this is an indicator variable from thresholds. So let's say that you are studying alcohol preferences by US consumers, and your dataset has an age feature. So this is that column that every record has age. You can create an indicator variable for age greater than or equal 21 to distinguish subjects who were over the legal drinking age. So, for example, we have multiple data for every person in US, and every person has a lot of traits, lots of features. So, for example, it has age, weight, height, and so on and so on. But for that specific model, you need to extract age feature. And let's look at the second example. So this is an indicator variable from multiple features. So you are predicting real estate prices, and you have the features n bedrooms and n bathrooms. So if houses with 2 beds and 2 baths command as a premium as render properties, you can create an indicator variable to flag them. So you can extract those two features from every apartment in your system, because every apartment has a lot of different features, like for example, how big is it, what region of city it has, and so on and so on. But we are interested in this specific analytical use case with those two features. Next example could be an indicator variable for special event. So let's say you are modeling weekly sales for an e-commerce site, and you can create two indicator variables for the weeks of Black Friday and Christmas. And let's consider such example like indicator variable for groups of classes. So you are analyzing website conversion and your dataset has the categorical feature traffic source. You could create an indicator variable for paid traffic by flagging observation with traffic source values of Facebook ads or Google AdWords.